Okay, in today's lesson, we're going to look at growth and decay equations, and these are based on your exponential functions. So let's stop and look back at your pink notes for just a second at your exponential functions. If you recall, it looks like this. And I just want to point out, remember it has an asymptote at y equals 0. And as long as my function doesn't go up or down, that asymptote's going to stay put. So today we're going to look at when we change the base and we play with this equation a little bit more. We're going to look at some characteristics that happen, but just want to remind you where that asymptote falls because we're going to need to use that as we graph. Okay, so let's look at number 1 here. It says complete the table and graph each exponential equation. So here it is. Remember, we're just going to use on all of these tables, we're going to use -1, 0, and 1 to keep it simple. Now, we're going to just plug in our work. So 3 to the -1, then it'll be 3 to the 0, 3 to the first. Now, if you remember, if it's a negative power, that means we take the reciprocal. Make it a fraction. So that 3 to the -1 is 1/3. So my y value is 1/3. 3 to the 0 is always a 1, and 3 to the first power is just a 3. So when I graph this, I want to start with my asymptote, make sure I can see it. So maybe set it a little bit above the x-axis, I don't know. Make it clear. And then we'll graph our points. At -1, this is at 1/3. At 0, it's at 1. And at 1, it's at 3. Okay, so remember, looks like that L approaches the asymptote but doesn't cross it. Look at number 2. Let's again plug in our numbers. 4 times 2 to the -1, 4 times 2 to the 0, and 4 times 2 to the first. So this is like 4 times 1/2. Well, 4 times 1/2 is 4/2, or if I put it 4 over 1, maybe you see it better. That really just reduces to 2. This is going to be 4 times 1, which is just 4. And this is going to be 4 times 2, which is 8. All right, so let's graph that. At -1, it's at 2. At 0, it's at 4. And at 1, it's at 8. Okay, it didn't move it up or down on my equation, so I'm going to keep my asymptote where it was. And then I draw on my curve. Okay? Look at number 3. That was a fraction. No big deal. 1/3 to the -1, 1/3 to the 0, 1/3 to the first power. Well, we take the reciprocal, that makes that a 3. Anything to the 0 power is a 1. 1/3 to the first power is 1/3. Let's graph this. -1, this is all the way up at 3. At 0, it's at 1, and at 1, it's at 1/3. So look, it kind of went the opposite direction. I did not put in my asymptote. Put in your asymptote. Don't do what I did. Put that asymptote in first. Now, look at our functions. Now, step back and look. I want you to see if you can catch any patterns about this. Okay? Look at the a value on all these equations. Now, this 3 is not a. This 3 is the b. So what does that mean? Well, that means that there's an understood 1 right in there. Okay? This is our a here, 4, and this one has an a of 1 also. All right? Now, notice for a second, if a was 1, what was our y-intercept? It was 1. If a was 4, our y-intercept was 4. If a was 1, it's 1. So guess what? You can begin to see that that a value will tell you what that y-intercept will be every time. The a value will give you the y-intercept, so it'll be 0, whatever a is, okay? So you don't have to really do any work on that. Now let's look at the b value. What does our shape look like with the b? Okay, our b value was a 3, and it looked like it was growing. Our b value here was a 2, and it's growing. Our b value here is a fraction, and it is, we call this decay. Okay, that is decay. So maybe you want to write that on there. This is a grow, this is a grow, this is a decay. Maybe you know that, maybe you don't. So let's look at what changed here with our b values. Well, these b values are whole numbers, aren't they? And this one's a fraction. So anything in that or anything raised to the x power that is between 0 and 1 is going to create a decay. If it's a whole number, it's going to create growth. So let's make ourselves a note here. All right, if b is greater than 1, that means growth. It's going this way, okay? If b is between 0 and 1, it's never ever going to be negative. If there's a negative, that negative is the a value, okay? The b is never going to be negative. If it's between 0 and 1, that means decay, and that means it's looking like this, okay? Looking like that. Now, let's use these little shortcuts as we do number 5 and 6, okay? We know that our y-intercept, look at that, it's going to be a -2. We don't really have to do any work there. But let's do the work for a -1. So -2 times 1/4 to the -1. Remember, that means I need to take the reciprocal, so it's -2 times 4. That gives me -8. This one will be -2 times 1/4 to the first power, so it's -2 over 1 times 1 over 4. If I multiply, I get -2/4, which is -1/2. Okay, when I graph this, my asymptote is still right here. Make sure I can see it. And let's graph our points at -8. Okay, at 0, -2. And at 1, -1/2. Okay, so maybe you can see what's happening here. It should make sense. It's the vertical reflection. It should be going this direction, okay? Look at number 5. All right, what's our y-intercept going to be? Well, that's that number right here. It's that -1. So let's plug in -1. So negative times 4 to the -1. So that's going to be -1/4. That a is a -1 times 4 to the first power is going to give me -4. Okay, so -1 to the -1/4, 0 to the -1, and 1 to the -4. Okay. And then my curve looks like that. So I want you to use these shortcuts to help you do the graphing. Okay, obviously you need to show your work on the -1 and the +1, but on the y-intercept, you don't have to show the work. Just use that a value to help you. All right, now let's talk about these word problems down here. Your job is to put these words into an equation. So let me give you some clues here. All right, remember, our equation looks like this. Y equals ab to the x power. Okay, now when you read these questions, this a value is going to be the initial amount that something starts as, okay? So these equations are going to describe growth or decay, and your job is to figure out which one. Well, all of them have an initial amount, and that is the a value of your equation. Now, what is the b? Well, the b depends on, is it growth or decay? Now, remember we said if it's growth, it has to be greater than 1. Remember we said that? So when you do this, it's going to be 1 plus whatever the rate of growth is. If it says decay, then it has to be less than 1. So it's going to be 1 minus whatever the percent is. Okay, because decay, we said, has to be a number less than 1, and we said growth has to be a number greater than 1. Remember that? Okay, so let's apply this. Let's look at number 6 here. $300 is invested in an account earning 5% interest, compounded annually. So let's look. $300 is my initial amount. Earning 5%, that would indicate growth, right? Now, when you do this percentage, when we do the 1 plus that percent, we need to make that a decimal, so 0.05. So when I write my equation, I'm going to say y equals 300 is my a. In parentheses, I'm going to say 1.05 and raise it to the x power, and that's it. Look at number 2. Caffeine is eliminated from the bloodstream at a rate of 12% per hour. A cup of coffee has 150 milligrams of caffeine. All right, here's my initial amount. Eliminated, hopefully, means you can connect that to a decay question. So it's going to be 1 minus my rate of change, which as a decimal is 0.12, so that's 0.88. So my equation will be 150 times 0.88 raised to the x power. A Les Paul guitar was bought for $12,000, so that's my initial amount. Experts estimate that its value will increase, that's growth, by 14% per year. So 1 plus 0.14 is 1.14. So y equals $12,000 times 1.14 raised to the x power. Now let's look at the last one. A car purchased for $18,700 depreciates, that's decay, right? A rate of 9% per year. So it's 1 minus 0.09, so it's 0.91. So it's less than 1. So y equals initial value times 0.19 raised to the x power. All right? Hopefully this all makes sense to you, and let me know what questions you have when you get to class. Good luck.